moderator for today. My name is Wilfrid Utz from BOC, and you will have as a presenter today Kostas Tsatsakis from HYPERTECH. Just to give you a little bit of insight what we will see today, we have scheduled this webinar for about 30 minutes. In the first step, I would like to give you an introduction to the organization of this webinar. So how can you interact with us? What is the organizational level that we will focus on afterwards. Kostas will then pick up on that one and provide you with an introduction to the project itself and discuss and demonstrate to you the IML layer. We conclude today's webinar with a Q&A session at the end. Depending on time, we will try to answer the questions that you have and come back to you otherwise individually. Just that you have faces to us as well. See Kostas on the left, who is the main presenter today, and myself on the right. At the end of the presentation, you also find our email addresses, so please feel free to get in touch with us and in case you have any further questions or information needs. How is the webinar organized? You should see a panel on your right. For your information, all your microphones have been muted by the system, so you cannot directly talk to us, and I would ask you to chat your questions directly to us. You have the chat window on the bottom right, and you can just leave your comments, your feedback, your suggestions in there. One important thing is that this webinar is recorded. So after we have finished the presentation, we will upload it to our website, to our social media channels, so that you also have the chance to follow up afterwards. I would now hand over to Kostas to start with the actual content of the presentation.
Hello.
Yes.
Now I will start sharing my screen. Good morning, everybody. I'm Kostas Tsatsakis from HYPERTECH, and as the first attempt, an attempt, this series of webinars is an attempt initiated by BOC, and we are the first presenter as a technological partner. HYPERTECH is involved in OrbEEt project as a technology partner of the OrbEEt framework, and I'm going to present the first layer of the overall architecture, which is the information management layer or IML layer of OrbEEt framework. Before starting with the presentation of the overall IML layer, I will have a brief introduction to the OrbEEt project. This is not a detailed, section, because we need to focus on the IML layer, just hinting the core ideas of the OrbEEt framework, the concept behind, and the main innovative aspects of the project. So the overall idea is to bring a behavioral triggering framework that will enable end users to actively participate, and the main objective of the framework is to enable energy efficiency in buildings, aka to lead on energy consumption reduction. The main innovation is that first we are going in low level, in device level, and monitor device consumption. We further incorporate business processes as a core element of the buildings that should be further incorporated in the analysis, because the occupants, the building occupants, are the ones that trigger the actual activities in buildings and lead to energy consumption. So we need to incorporate this very important parameter to the overall analysis. And further, by having this, incorporation, business processes, and real-time energy consumption data coming from devices and from sensors, we further process this data in order to provide accurate messages to the end users through an enhanced display energy certificates framework. So we move beyond the current EPC energy performance certification framework, which is static, to a more dynamic one that enables the end users to drill in real time to building level information. And further, we have an innovative gamification framework that takes into account personalized information as derived from business process analysis and sends the right messages to the end users to ensure a more active participation of the end users to the building operations. So the scope of this webinar is to focus on the sensor data, which is the first aspect of the OrbEEt framework, and how data from end devices, from the different devices of interest in the project, we will be further provide information to the platform. We have followed the typical requirements definition, specification analysis and design, development of the tool, and further pilot validation and testing methodology. We are now in the second year, in the third year of the project, so we are in the middle of pilot validation and testing. We have developed the integrated framework of OrbEEt, and now we are at the process of evaluating the overall framework at the 4 different pilot sites of the project. So we have buildings in Austria, Germany, Bulgaria, and Spain. Different types of building. We have museum, offices, municipality buildings at different geographical regions of Europe with different weather conditions, with different building occupants characteristics in order to have this multi-criteria, multi-diverse evaluation of OrbEEt framework at different pilot sites. This was the brief overview of OrbEEt framework. Now we are moving to the core of this webinar, which is the IML layer presentation. As said before, as briefly said, the initial part, let's say, of the OrbEEt framework is to collect real-time data in real time from the different device types. So we are not getting total energy consumption once per month or once per semester, but we are drilling down, we are getting data in 10 minutes granularity from the different devices types. And in order to do this, we need to set a hardware and software framework that enables us to gather the data required for this level analysis. This is actually the goal and objective of the OrbEEt information management layer, to collect energy use data from the wireless sensor network devices and further process this data in order to extract meaningful information that will be further used for further analysis at the application layer of the OrbEEt framework, which is the OrbEEt Systemic Enterprise Operational Rating Engine. We are focusing on 3 different building elements, let's say. We are monitoring ubiquitous loads, which are HVAC and lighting, which are, from our side, is the most important devices in terms of energy consumption in buildings. And further, these are the devices that can be further correlated with the environmental conditions and occupants' personal preferences in buildings. We also monitor office equipment loads in order to have a holistic view on the building energy consumption. And also we monitor the environmental conditions in buildings, namely temperature, humidity, and luminance levels, information that will be further correlated with the operation of HVAC and lighting devices towards a more accurate modeling of DER operation that will further enable us a better understanding about the operation of these devices in buildings. Starting with the hardware part of the analysis, the first part of the work was to select the wireless sensor network protocol to be considered in the project. After an extensive analysis of the different standards or of the different approaches that are commercially available, we selected the Z-Wave network protocol as a wireless protocol that is common for residential and light commercial applications. The main drawback, starting from the drawback of this protocol, is the fact that it's not an open or standardized wireless sensor network protocol. So there are some constraints or some limitation about the usage of this protocol. But the main benefit from using this is that we have a commercially available solution supported by Z-Wave Alliance, which is a mature alliance which focuses mainly on the commercialization of the solution. There is an active community providing support to the deployment of that type of solution. As a main benefit from this solution is the fact that it's a mesh protocol, so we can easily scale to a building environment. We can put different devices, and these are all of them getting connected. This is a drawback of an ocean, also highlighted in this table. And also in contrary to Zigbee, Zigbee is mainly for academia and research. The protocol enables to extend the functionalities provided by the protocol to define additional layers at the standard. but it's mainly, and this is a drawback, for research. On contrary, Z-Wave is a commercially available solution. It's a mature solution, and this facilitates our work in the project, where the focus is not on the construction of additional elements, but further on exploitation of commercially available solution towards a rapid deployment of the OrbEEt framework at the different pilot sites of the project. Then, by having a quick review of the Z-Wave devices available in bibliography, we have selected the ones that best fit to the different use cases examined in the project. So, of course, as any other wireless network, we need to have a gateway in order to communicate with the different devices. And further, this gateway acts as the endpoint at the building level to report data to our application. And further, by having this gateway as the heart of the system, we select smart plug devices for monitoring plug loads, smart switches for monitoring mainly lighting consumption and also HVAC consumption, electrical HVAC consumption. We need to have also multisensorial devices to gather information about the different building contextual conditions. And range extender is an add-on device that provides a reliability to the wireless sensor network. As you can see, the pricing is around 50 euros per device, so you can easily scale and define the cost for the deployment of a solution like the one defined in the OrbEEt. A snapshot of the different devices selected. I'm going to give an overview. Though we didn't go with an open source solution, an open source hardware solutions, we did an effort and select an open source software available gateway. This is the Raspberry with Z, not with S, which is actually a Raspberry device, where on top we put this Z-Wave antenna. This is the add-on to the Raspberry, and then the core of the software of the IML layer is running in the Raspberry Pi, which is a low-cost PC device that enables an easy deployment of the IML solution at the different pilot sites. So here we have the open source software running to enable the communication with the different hardware devices and further with the rest of the OrbEEt application. A smart plug, it's the common smart plug, the Fibaro smart plug selected for the pilot site. The smart switch, the antenna to connect to the network, and also the places where we cut the power and then we connect the power in order to first monitor the consumption of its device, and second, be able to control the operation of the specific device. As said before, we mainly use this device for monitoring the consumption of lighting devices in the project, while the control functionality is not considered as a use case in the project. The third device type examined is the smart clamps for measuring energy consumption at the different device types, avoiding having this cut-on, cut-off of the power. So it's an easy to deploy solution for measuring energy consumption. This is the range extender that ensures reliable connectivity among the different devices. And this is a fancy device. This is a multi-sensor device. Enables us to monitor motion. There is a PIR sensor on board, temperature, luminance, humidity, and ultraviolet measurements. We are not using motion and ultraviolet measurements in the project, but we use the rest in order to have a context-based, a context-triggered framework in the project. This is the high level, the conceptual view of the information management layer. So now we are moving to the software part, which is the part developed in the project. From HYPERTECH, this software development stands in the Raspberry Pi and further interfaces with the rest of the system components. So starting bottom up, we have the different devices types with the respective sensors connected there. We have the Z-Wave gateway, gathering the data from the different hardware devices, reporting data to our cloud information management layer core application for persistence reasons, for storing the information and further routing this information to the rest of the business applications of the OrbEEt framework. A more detailed view of the OrbEEt information management layer. Consider this as the functional view of the software component. As said before, we have the interconnection with the physical devices. Then we define as part of the information management layer the semantic components that handle the raw information coming from the different sensors. So for example, if we have 3 temperature sensors in a specific room, this semantic component named as temperature sensor is responsible to handle the measurements from these 3 devices to provide cleansing and normalization over the data, and further provide an average estimation of the temperature consumption in the building. So we don't only get abstract raw measurements from the devices, but we add additional semantics in order to extract meaningful information from the different device types. This information is also stored in a local database for persistency reasons. And also we have this event manager component that, considering the subscribing method adopted in the project, enables us to report ad hoc messages to the rest of the applications. So we are not based on the request response message. We are not waiting for a request from a different application. Rather, we publish any new information retrieved from the wireless sensor network to the different business components of the OrbEEt framework. So this is a summary of what is the information management layer about. It's about provision of interfaces with the physical environment, with the physical world, interfacing with the actual hardware components through a gateway device, defining a single point of access of data. So this is transparent for the rest of the system. The rest of the business application interfaces only with the information management layer. This information management layer is about event-based analysis. So we rely on data when generated. It's about providing semantically enhanced data, not only raw streams of data, but further semantics on top of this data. And it's about logging and storing the data streams as coming from the different devices for further analysis. A typical snapshot of the database on the way we are handling this information. This is not that complex, but this is the philosophy behind information management layer, to have a hierarchical structure on the way we manage the data from the different pilot sites. And in order to have a more, let's say, visually appealing view of the information management layer, we stop now the presentation of the foundation about information management layer, and we are going to provide a short demo of the software, of the tool that is used for monitoring the information management layer of the OrbEEt framework. So we are now going to have a connection to the OrbEEt VPN network. So we have a secure network in order to avoid having external connections to our system. We are going to get connected to a pilot site, to the Asparena pilot site, to the gateway that's placed there. And we're going to have a view on the GUI of the IML layer in order to monitor the status of the system. That before going to the specific deployment in Asparena pilot site, this is the project portal OrbEEt, where you can find the material of the project, additional information about the project activities, and further, after this telco, you are going to have a specific session with a webinar information presented for post analysis. So now going to the Z-Wave gateway that is placed in Asparena pilot site. As you can see in my screen, now we are connected to the VPN of the project, and we have access to Asparena pilot site. The core functionalities, this is the main view of the system, where you can easily go and see the current status of each sensor placed there. You can see the voltage level, you can see the consumption level of specific devices. This is the full list of the devices. You can even select types of devices or search for the type of device of interest. And further, you can have this, let's say, taxonomy of the devices to the different building zones of this gateway. So this gateway is now responsible for monitoring the status of 3 offices in Asparena pilot site, and we have associated the different devices to the different building zones of the building. Also, we can have additional features supported by this GUI, additional apps. Consider this as, let's say, the Google Play for the gateway, where you can go and install different devices for monitoring several hardware components, or even providing additional functionalities on top, taking into account the data available from hardware devices. We have settings about the rooms, personal settings, management settings, having to do mainly with user management, upgrade of the software, and so forth. So typical software management functionalities. But the core is the devices, is the view of the system that enables us to manage the different hardware components that consist of the wireless sensor network of each project. In this specific case of the Asparena pilot site, we can add new devices through this button, where we can auto-detect new devices and proceed that way to have a configuration process. We are not going to do this because we have already configured the devices at the pilot site. We can manage existing devices. So we have a list of devices already installed and monitored for the good of the project, for the different activities performed in the project. And apart from this, add new configuration, let's say functionality, and manage existing hardware. We have this expert view developed that enables us to go and get insights about the operation of these devices. So from this console, we can go and see the status, the real-time status of the hardware components that set the wireless sensor network. So you can see what are the device types monitored. We have defined a specific name that indicates, let's say that way, the type of the device monitored. You can see that we have desk devices, we have multisensorial devices, we are monitoring light consumption, we are also monitoring HVAC consumption, and PCs, mainly PCs, are the main office devices available in the municipality of Asparena. And further, we can see what we can switch, what we can control. This is not of interest for the project, but we can also see what is the latest value, latest monitoring value from each specific device that set the network of the pilot site. As you can see, we are getting data about temperature, real-time data, in 10 minutes granularity, power consumption, luminance data, humidity data, aggregated electricity consumption, along with voltage and ampere levels. So we are getting the information, we are gathering the information required for our analysis. The number of metrics, as you can see, indicates the number of sensors installed. So, for example, you can see that we have 5 different values about temperature. These values are associated with the different sensor devices placed at the different zones of the building. Also, we have the functionality of configuring. This is an expert view about configuration of the different device types. So by selecting a monitor, you can see you have an interview complete. What are the results of this process? As you can see, we are monitoring not only functional, let's say, attributes, but also non-functional technical attributes having to do with the connection, with the connectivity of the device to the network. So, for example, this firmware update or association is having to do with Z-Wave functionalities, not that meaningful in terms of functionalities offered by this device, because this device is only about power level and meter consumption, but also additional information that may be useful for evaluating the network connectivity. Also, as a last, let's say, view of the system, we have this control functionality. This tab enables us to have a better network monitoring, where we have the removed failed nodes functionality. We have a network maintenance view in order to add or remove devices from the network, and this routing functionality that enables us to have a quick overview of the network connectivity of these devices. So this is the heart of the network, of the Z-Wave network deployed in Asparena pilot site. As you can see, we are facing a problem with this device 19, where there is no connection with any other node of the system. For the rest of the devices, you can see that we have strong or not that strong connectivity, but even this weak connectivity is enough in order to set the network. And this, coming to my initial words in this presentation, is a core, let's say, aspect of this Z-Wave network that sets a mesh connectivity. So maybe this device, paper shredder, is not directly connected to a specific device, for example, this one, but through this mesh network, we enable to have a connection with the rest of the devices up to the Z-Way, which is the gateway of the system. And about this device 19, I left it on purpose here because this is a range extender device. As said at the beginning, this is not a functional device. This is only a device that ensures reliable connectivity. We have left this. We know that the current status is that this device is not connected to the network. We're going to remove it after this telco, but the reason on having this device is to show that we can easily monitor through this screen the current status, the current health of the network, and go quick and modify, reconfigure, reorganize our network in order to have a stable network. Overall, the IML functionality, the IML layer is about establishing the hardware network by selecting the appropriate hardware components required for the different applications, setting the software in a Raspberry device unit that enables us to quickly set up a network with the devices, and standing on top of the software that sets, let's say, the middleware to the hardware components, building our own applications that enables us to develop extra functionalities. And this is exactly what we did in the project. We took into account the basis of the middleware provided by open source community and built on top additional services that enables us to remotely access the different hardware components at the different pilot sites, to gather data, low-level information data, device-level information data at a selected from us time granularity. We have selected 10 minutes time granularity. And then we have built on top additional services, web services that report processed data to the business applications of the framework, of the OrbEEt framework in our case, but these services could be further exploited as typical web services to different business functionalities. So consider this as the gateway, as the layer of interconnecting a software system, a software platform with a physical environment, selecting low-cost devices for residential and light commercial applications, and having a rapid deployment of wireless sensor network solutions at building level. This is the end of my presentation about the information management layer. More information can be further visualized at our project portal, orbeet.eu. And I don't know if you have any questions about our software development. If not, I'm passing.
Right.
Yes.
Thank you very much, Kostas. That was really interesting. You gave a great overview of the IML layer and how that actually works on an actual implementation in Asparena, so we could actually see the live system. I will just take over from here and would open the question and answer sessions. But looking at the time, I think we are actually at the 30 minutes spot already. So I would ask you to continue to post your questions into the chat, and we will follow up on these questions afterwards via email. That leaves me with the final slide of today's webinar. Thank you very much for joining. You find on this page our contact details in case something stayed unclear, or if you would like to get further information. Also, as an announcement, all the things that you have seen today, the recording of the webinar, plus the slides, plus the demonstration screens that were available, will be made available on the OrbEEt website, orbit.eu, and you're kindly invited to download, ask us critical questions, and come back to us as soon as you can. Thank you very much for joining.